Now let us refer to the concept of bundled conductors. Now what is the purpose of this topic means, or the bundled conductors means, if the operating voltages are beyond 270 kV, then we need bundled conductors. That is the main point here. Now in order to understand the concept, first you identify these two diagrams. Now these two are the towers. The first one is having only single conductors and the second one is having bundled conductors. Now from these two diagrams you identify the important points. Now here first tower is there. Now here these are the three phase representations: R phase, B phase, Y phase. Now each phase is separated by a distance 10 meters. Now we call this as the mutual distance. It has a mutual distance. Now R is the radius of each conductor, single conductor. Okay. Now regarding the second diagram, this is the tower having bundled conductors. Now here each phase is having two subconductors. We call these as the subconductors. Now R phase having two subconductors, B phase having two subconductors. Now what is the difference between these two diagrams to identify means, here the radius of single subconductor is 3 centimeters. Now it has been reduced. Now here R is 1.5 centimeters. Now you got one extra point to identify, S. S is the spacing between the subconductors. Now the spacing here in this example is 15 centimeters. Now you identify the important point here. The radius will be very less than the spacing between the subconductors. Now what are the three important points from these two diagrams means, the mutual distance in the both the cases will be same. The radius of conductor, which is R, has been reduced. Now you got the extra condition or the extra point here, spacing between the subconductors as S. Now in comparison, R is very greater than, S is very greater than R, and the mutual distance is also very greater than S. Now if you continue the topic, now we had considered single conductor into bundled conductor. Now regarding the bundled conductor, if you go for the important points which I had referred, it consists of two or more subconductors per phase. If you identify the diagram, here you got two conductors which are subconductors here. It may be more than two also. They will run in parallel, but their spacing between them will be very high. So here if you can extend the diagram, the conductors, the subconductors will be like this. They are parallel to each other, but the spacing between these two will be very high when compared to the radius of the subconductors. Now in order to calculate the radius of the subconductors, you can have this diagram. Now here R is the radius of single conductor, and here these R1, R2, R3 and so on are the subconductors. Those are representing the radius of the respective subconductors. Now if you identify the equation here, R square, which is regarding the radius of single conductor, is equal to R1 square plus R2 square plus R3 square so on to Rn square. Okay. Now here these are the radii of the subconductors. Now using this equation you can find the radius of each subconductor like this. So if you refer this diagram or the equation, assume all the subconductors are similar and are having the radius as R1. Then the above equation, this equation becomes R square equals to R1 square into N. What is the reason? We are considering all the subconductors are similar. Nothing but all the radii of each subconductor as R1. So then it will become R1 square into N. Now from this you will get R1 equals to r by root n. So for this simple calculation is there. So r1 square equals to r square by n from this equation. Okay, now again r1 equals to root of r square by n. So this becomes r1 equals to r by root n. So this is the resultant equation we got, which represents the radius of each subconductor. Now let us assume there is only a single subconductor. Then what is the radius means? r1 equals to r by root of 1. Just substitute 1 as a number of conductors equals to 1 here. So the radius is r. Now if you got 2 subconductors, then what happens? You substitute n equals to 2. If there are 3 subconductors, just substitute it as 3.